Today I'm going to be introducing adding and subtracting radicals. So what we have done already in this unit is adding, subtracting, and multiplying polynomials. And a lot of the same rules are going to apply here. But I need to talk about a little bit of terminology first because I'm going to be using these terms. Coefficient is a term that you are familiar with. A coefficient is a term in front of a variable. Like 3x, the 3 would be the coefficient. In this case, the coefficient is the number in front of the radical. You already know the radical sign, that's the square root sign that you're used to calling it. But the new term is the radicand. Okay, a radicand is the number that is underneath the square root sign. So whether that number is a 3, it's a variable like an x, or whatever it is, that is the radicand. So when you're adding and subtracting radicals, there's one main key rule that you have to know. To add or subtract radicals, the radicands must be the same. It is treated like a variable, and you combine it just like you would combine like terms. So I have some examples down here. 2 square root 3 plus 4 square root 3. The radicands are the same. They are both square roots of 3. So all we do is add the coefficients. Okay, so we add 2 positive 2 plus 4, and we get 6 square root 3. That's it. Over to the right, we have negative 6 square root 2 minus 3 square root 2. So again, the radicands are the same, so we just add the coefficients. Negative 6 minus 3 gives me negative 9 square root 2. And then over here we have 7 square root 2 plus 6 square root 5. On this one, the radicands are not the same. These two terms cannot in any way, shape, or form be combined. So this is not anything that can be simplified, so your answer is simply 7 square root 2 plus 6 square root 5. It's already simplified. It cannot be simplified any further. So you should notice that these have those same rules for combining like terms that you had with variables. You add and subtract the coefficients of like terms. Now, here's the thing. Same rules once again. So here we have two binomials. And we're going to be subtracting them. That's the subtraction sign in the middle. Okay, so first I've got to change my signs by distributing the negative sign. So I'm going to distribute the negative sign to both of these. So this becomes a negative, let me change the color. This becomes a negative 3 square root 2, and this becomes a positive 7. When I do that, this negative sign is gone, and we're now adding these like terms. So I'm going to be doing 2 square root 2 plus 3, and then I'm going to write my new terms underneath it for the like terms. So negative 3 square root 2 goes here, positive 7 goes here. So my combining like terms would be negative 1, I don't have to write the 1 though, oh, that's supposed to be a 2. Negative 1 square root 2 plus 10. That's it. Okay, that's all there is to it. But of course, as you know, everything gets a little bit more complicated, so sometimes you have to simplify the radicals to make them have the same radicand. So I want you to look at this example. Here we have negative 4 square root 2 plus 3 square root 8. Now, on first look, you may be thinking, oh, well, they don't have the same radicands, so I can't simplify them. But that is untrue, okay? If you have something that can be simplified, if one of your radicands can be simplified, then you have to simplify it before you can say that you don't have any like terms. So you have to ask yourself on every question, can something be simplified? And if yes, you must simplify it. So here you'll see where I have simplified 3 square root 8. So started off by simplifying the square root of 8 and got it down to 2 square root 2. That's right here. Okay. Now, the 3 came down. You can see it came down right here. So now I have 3 on the outside with a 2 square root 2. So this 3 and 2 have to multiply together, and that gives me 6 square root 2. So you then replace the new simplified radical and simplify. So my original problem was negative 4 square root 2 plus 3 square root 8. 3 square root 8 simplifies to be 6 square root 2, so I have negative 4 square root 2 plus 6 square root 2. My final answer is 2 square root 2. Okay, so this is going to be a big issue for those of you who go quickly and don't pay as much attention as you might, and we're all guilty of it sometimes. So you really have to pay attention to what can and cannot be simplified. Okay, so let's look at this problem. Now I've already worked it out, but I want to take it piece by piece. Notice this little note I put over here. You must be able to recognize what can be simplified. So I look at this problem right here. 3 square root 5. I look at it and I say, okay, I can't simplify that. It won't break down. 5 cannot be simplified. I look at the next one and I see 6 square root 12, and in my mind I think, bam, square root of 12 can be simplified, so I got to simplify it. So I break it down, 12 to 6 times 2, keep going, and I end up with 12 simplifying to be 2 square root 3. I look over at the or 2 square root 3. I look over at the next one, I see 27. Again, bam, it can be simplified down to 3 square root 3. So you'll see down here, I've got to multiply the term that was already on the outside that I brought down. So I now have 6, 2 square root 3, and negative 6, 3 square root 3. So I multiply those together. So now I have 3 square root 5 plus 12 square root 3 minus 18 square root 3. Okay, so this 5 still doesn't have anything to join with, so it comes down to the answer by itself. Combine my square root 3 like terms, and I have 12 minus 18, which is negative 6 square root 3. That is the final answer. So you have to be very careful with these and make sure that you pay very close attention and that you simplify these correctly. This is why we've reviewed simplifying radicals, because I told you it was going to be coming back up in this unit. So that's it for the simplifying radicals and adding and subtracting radicals.